like I said before, we're going to be talking about linear equations and inequalities. And we'll start with some linear equations before we move on to inequalities, and we will work without fractions and with fractions. I find that people are pretty good at this stuff as long as there's no fractions. But people see fractions and their brains go, and so we gotta make sure that changes. Okay, we gotta make sure that you're not afraid of fractions because, well, there's a lot of fractions in pre-calc, especially and in trig. Oh man, trig is covered with fractions, so we just got to be really, really comfortable with those guys. Okay, so we start with this good question right here. I mean, straight up and down, algebra 1 or 2-ish, depends on where you learned it, who you learned it from. But when you see a number on the outside of parentheses in mathematics, basically it means distribute. That's what we'll do first. I'm going to distribute this 2 to both of those objects, and we'll distribute this 3 to both of these objects. Now, before I actually do the distribution, I want to mention something that's not in this question. And I don't know if it's going to come up in later questions, so I want to make sure I say it now. This symbol right here happens to be a plus sign. But if this was a minus sign, it's not a 3 that you're distributing there. If this was a minus sign, you'd be distributing a negative 3. And you need to make sure that you don't forget that, because I know me, that's probably what's on the test, okay? Because I'm checking for basic algebra skills with that kind of question. So when I say things like that's probably what's on the test, and I do like this with my eyebrows, which you can't see in the video for YouTube, but they went up really, really high, that's a clue, okay? So you guys are always welcome to write more than I do. Actually, you're encouraged to write more than I do. Like maybe leave yourself a little note about what happens if that's a minus sign, things like that, okay? All right, let's distribute that first 2. 2 times 2x, or 4x, and then minus 2 times 3, 6. Again, I'm distributing a positive 3, not a negative 3, so it's actually a much easier question. Distributing 3 to the 3x plus 3x, and the 3 to the 1 plus 3. Typically, what you're trying to do is get all your x's to one side and all your things that are not x's to the other. But if you notice on the left side, I have x's in 2 different places. So these 2 objects right here can be combined. And I see some algebra 1 / algebra 2 mistakes right here sometimes, where people think, oh, I have to, subtract 3x from right here. No, you don't. These guys are on the same side of the equal sign. So as long as they're on the same side of the equal sign, you just follow the operation that's in front. You could basically pretend the negative 6 isn't sitting there. They go, oh, well, 4x plus 3x. That's where we're going to get our 7x from. That says 76. I'm not quite sure what happened to my brain. I always cross my 7s. It's just something I developed the habit of doing because my handwriting is not always the best. So I cross my 7s. Oh, I also cross my z's. And that's how you know it's not a 2. Because like I said, we're looking at like a 3rd grader's handwriting here. Just have poor handwriting, I'm sorry. So you never have to wonder, is that a z or a 2? Because if it's a z, it'll have a cross in the middle of it. Okay? You'll see. We'll get there. And now the same trick is going to happen between this negative 6, because it is a negative 6, and this positive 3. I could just pretend that 3x is not there, so it says negative 6 plus 3, which is going to be negative 3. And now we'll go ahead about the business of moving all the x's to one side and all the non-x's to the other. If I can, I like my x's to not be negative, so I typically move them to wherever there's more of them. I guess that's a good way of saying it. So I'll take this 5x and move it to the left by subtracting 5x from both sides. And in the exact same step, because, well, less steps is better, I'm going to take this negative 3 and move it to the right. And you might be noticing why I suggested lots of colors. So it shows you exactly what I'm doing. On the right side, those guys canceled. And on the left side, those guys canceled. 7x minus 5x gives me a 2x. And 2 plus 3 is 5. Then you just divide both sides by 2. And that is how you're going to end up with x equals 5 over 2. Fractions are our friends. Could I call that 2.5? I could. I'm not going to. I'm going to leave it as 5 over 2. a lot of math is much easier to do with fractions than it is to do with decimals. So fractions are our friends. Nice little warm-up question. If you have any questions for me about anything that you saw, please say something. Let me know what I can do to help. Because otherwise, I have to assume that everybody got it and everybody's cool with that and can reproduce that at home. Good? Okay, I didn't hear any no's, so we will move on then. Fractions. I got it. It's okay. Not a big deal. I got you covered. Okay. Fractions are not scary. I promise you they're not scary. But Mr. M, I don't like fractions. And I go, okay, well, you're a lot like most of my students. Most people don't like fractions. And I said, well, if you don't like fractions, well then get rid of them. Get rid of them. And then you don't have to deal with them, right? In order to do that, what you need to understand is that a fraction bar literally means divide by. So if you would like the divide by to go away, you use its inverse operation, multiply by, okay? So this says divide by 8. If I don't want to see an over 8, all I have to do is multiply everything by 8. And if I do that, guarantee this fraction will go away. Well, the bottom of it will go away. But Mr. M, there's another fraction. Ah, I see you. Yes, there is another fraction. Here's the good news, though. The least common denominator, meaning the smallest number that this 8 and this 4 can both become or both go into, happens to be 8. So when I distribute an 8 across this equation, and make sure I do it carefully so I don't goof anything up, actually, both fractions will disappear. Mr. M, what if it wasn't a 4? Let's say it was something like 3. Yeah, 3 doesn't go into 8. So what would we have done? What you would have done is you would have looked for the least common denominator between the 8 and whatever this number is. Say if I'm shaking. Say if it was a 3. Least common denominator between an 8 and a 3 is 24. So you would have distributed a 24. That would have gotten rid of all your fractions. So when the denominators don't match, or when the denominators are not one being a multiple of the other, your job is to distribute a least common denominator. And then no fractions. Hopefully that'll come up somewhere else in the notes so I can demonstrate all the things I just said. So we have to distribute this 8 to everything we see. There are 3 portions here. Things that are separated by pluses and minuses are the objects that we're looking for. So we're distributing 8 to this fraction, 8 to this number, and 8 to this fraction. That's what we're doing. It's going to all 3 places. I will show that happening. I'm not going to skip any steps. Starting on the left, I will have an 8 outside of a 5y minus 2. Still have an over 8. Here I have a 2 times 8. And then here I have an 8y over 4. Hopefully you will have noticed that when I distributed to the fractions, I only multiplied to the top. When you multiply a number to a fraction, a whole number to a fraction, it only goes to the top. The only time anything goes to the bottom is if you're multiplying by another fraction. Okay? Now it's time to reduce our fractions. That way they go away. Well, 8 and 8 cancel because they're both 8. That makes life easy. One on top, one on bottom. And then over here, 8 divided by 4 is 2. So this 4 is gone. This 8 is replaced with a 2. Leaving me 5y minus 2 equals 16 plus 2y. And now it's legitimately an algebra 1 question. Get all of the y's to one side and all of the non-y's to the other side. Just like I said before, if I can, I try to avoid negative numbers in front of my variables so I don't have to divide by negatives. So I will move the 2y to the left, and at the exact same time, trying to save time and space, I will move the 2, which will become positive 2, to the right side. These 2's cancel, these 2 y's cancel, and I get 5y minus 2y. equals 16 plus 2, 18, and divide by 3. Boom. So, hey, look, if you got questions, I expect you to ask them. The last thing you want to happen when we're going through our review prerequisite material is for you to go, oh gosh, I don't want to look like I'm dumb. I better not ask a question. You know, nobody wants me to ask that question. Well, basically, if nobody wants you to ask that question, they can suck an egg because who cares? It's your education. You got a question, you ask it. And what can I do for you? So why did I choose an 8 up here? Then is the question. Okay, so imagine I'll use a pencil. Imagine it just was slightly different, and it just said 1/8 plus 1/4. And I just said, hey, I need you to, you can't see what I'm saying. I needed you to add these two fractions. Well, you can't add fractions unless they have the same denominator. So our job would be to figure out what is the least common denominator here. And again, luckily, this 4 could become an 8 if I multiplied the top and bottom by 2. So now it would say 1/8 plus 2/8, which would allow me to get the 3/8. So the same trick is happening here where I just look for the smallest number that both this 8 and this 4 could become. And luckily, 8's already 8 and 4 can become 8. Now, could I go with bigger? Could I have done could I sometimes do so? Well, couldn't I have just multiplied everything by 32 because that's what 8 times 4 is? Yeah, you can. That'll work too. It's just that you're going to be dividing larger numbers, but you get the exact same answer. So do you have to have the least common denominator? No, any common denominator will work. Just least makes numbers easier. Cool. All right. Anybody else? Good question. No? All right. Well, then we will scoot on down to something that's almost like a conglomeration of the first question and the question we just did. Going to have to do what looks like a couple distributions, and I have a fraction. So I know somewhere I'm going to have to distribute. I know I'm going to have to move some stuff. I know I could maybe cancel a fraction, maybe just distribute it. Look, the good news is it actually doesn't matter which method you choose as long as you follow PEMDAS. Well, and then reverse PEMDAS whenever you're solving for X, you're using reverse PEMDAS. But I'm going to tell you what I see as a trained mathematician. I see that if I distribute this 1/2 to this number, I'm going to have to play with a fraction. And honestly, I find most students are not comfortable playing around with fractions. So because distribution here would have caused me to have a fraction, I'm not going to distribute that. If it was not going to cause a fraction, I would distribute it because then it would be easier. So let me show you what I plan on doing here. And by the way, you are welcome to distribute it. That method would work also. Just again, a lot of people aren't comfortable with fractions. What I would do is I would distribute the 3. And once again, like I said before, it happens to be a plus sign, but if it was a minus sign, you'd be distributing a negative number. Just be careful with that. And I'm going to leave it as a 1/2 in front of 2x minus 3. Then here I have a plus 3x plus 3. And I've done nothing over here. I don't like the 1/2. It's a fraction. So what I'm going to do is I'm going to make it so that I can get rid of that fraction. And it doesn't matter if I get rid of it right now or if I wait a moment and get rid of it in just a moment. It's completely up to you. But what I'm going to tell you is that I'm going to wait a moment and I'm going to isolate the structure that has the fraction. That's what I'm going to do first. So I'm going to subtract this 3x and I'm going to subtract this 3. This will get the structure that has a fraction in front of it alone. So I got this 1/2 sitting 2x minus 3. Everything else on that side is gone. On this side, I have an x minus 3x, negative 2x, and a 2 minus 3, negative 1. And then I'm in a spot where getting rid of the 1/2 will be pretty darn easy. So again, if you don't like fractions, get rid of them. Remember, a fraction bar means divide by. And just like before, we cancel divide by with a multiply by. So to cancel this divide by 2, I'm going to multiply by 2 on both sides. I'm going to distribute this 2 to all of the individual parts. And remember what I said earlier. Individual parts, individual terms are separated by pluses and minuses. What that means is on this side of the equation, this is one term because they're not separated by a plus or minus, they're separated by multiplication. So that 2 comes to this side. Then it goes to over here where it has to multiply to everything that's separated by a plus and minus. What that gives me on the left is, and again, I'm going to show a lot more work than you need to. It's going to give me a 2 times 1/2 times 2x minus 3. And over here, it's going to give me a 2 times negative 2x. That's negative 4x. And a 2 times negative 1. That's negative 2. And I did it this way so that I could show you 2 halves equals 1 whole. They just turned each other into a 1, so they're gone. Alex, yes, sir. So you got 4x minus 6 because you distributed this 2 to inside of these parentheses. But this 1/2 and this set of parentheses are separated by a multiplication dot. Let me show you what I'm talking about. Grab a small piece of paper here. I'm going to avoid fractions just for a moment, okay? So let's just say, for the sake of argument, you had a 2 here, and inside these parentheses you had a 1 plus 3. Okay? Now I know you could combine the 1 plus 3 and get a 4, and I know that 2 times 4 is 8, right? So we know that this has a value of 8, correct? Now let's just say, because it works well for my argument, that you wanted to multiply both sides, quote unquote, by 3, right? Let's just say you wanted to do that. Do this and this. So what we know is all of this mess had better equal 8 times 3, right? So it better equal 24. But what I'm saying is you are not going to do this 3 distributed to this 2 and this 4. You don't get to put it to both. This 1 plus 3 became this 4. The reason why is because this 2 times 4 is 8. But if you multiplied the 3 to both of them, you'd have 6 times 12, which is not 24. So again, what made it different was that. That dot is what changed this problem for us. If this dot had been a plus or a minus, then yes, this number here would have been distributed to here and here. But because it was multiplication, you literally just multiply straight across as one number, okay? Actually, I was hoping someone would ask. Does that clear up why it didn't go to the 2x minus 3? And trust me, you weren't the only one. You're just the one that spoke up. So here I have a 2x minus 3 equals negative 4x minus 2. And I am going to need to move all of my x's to one side and all of my non-x's to the other again. I like my x's to not have negative numbers in front of them, so I'll scoot them to the left, which means all of my non-x's are going to go to the right. I keep forgetting to put that red equal sign. Two x plus 4x gives me 6x, and negative 2 plus 3 gives me 1, and divide by 6. Fractions are out. we're going to leave this answer as 1/6. That decimal repeats anyway. Nobody likes repeating decimals. So yeah, that distribution of that number only to the fraction was what made this question unique. Any other questions on it though? Be happy to field those. No? All right. Then let's flip it over to get to the inequalities. At the beginning, there's not going to be anything really different from what we were doing before. We treat them as equal signs for most of the time. That means distribution will be our first step. Distribute this 3 to here and here. And nothing has happened anywhere else. Combine my terms, -3 plus 2, that's -1. Okay, now, if this had said equals instead of less than or equal to, then this would have been a little bit easier question. Not a lot easier, just a little bit easier. You see, the thing about inequalities is when you answer them, generally it's much easier to understand your answers if the variables are on the left. It's just easier to read. Oh, x is less than some numbers, or x is greater than some numbers. It's just easier to understand and talk about it like that. So because of that, I am going to bring my 5x to the left. Now, I don't really enjoy negative numbers in front of my variables, but for inequalities, like I said, it is easier to understand the answer when the variables are on the left. It's going to give me, well, 3x minus 5x, that is negative 2x, less than or equal to 6 plus 1, 7. Yes, ma'am. Oh, the plus 2 went right there, became that -1. -3 plus 2. Because it's not 3 plus 2, it's -3 plus 2. We have to remember that the symbol in front of the number belongs to that number. That's a -3 plus a 2. Last thing you need to do is divide by a -2. But something special is about to happen. And this is the kind of thing that you might want to write down because I'm not writing these words. You might want to if you don't remember this rule. But when you divide or multiply by a negative number on both sides of an inequality, it switches the sign. So this would be a wrong answer choice on my test. That is not true, but it's waiting for you. Because I divided by a negative sign, you have to flip the inequality symbol over. And that's true if you multiply by anything that's negative as well. So the true answer is x is greater than or equal to -7/2. That is what you want. And that's because, again, I multiplied or divided both sides of an inequality by a negative sign. This one's waiting for you as a wrong answer, though. Okay with that rule? All right. Good. Then the last question of this set of notes before we get on to the next one, and hopefully I can get the whole next one finished. Look at all those fractions. Remember I was saying I was hoping that there'd be one that had multiple denominators? There it is. I have denominators of 2, 3, and 4. And boy, oh boy, it would just be nice if we didn't have to deal with fractions, wouldn't it be? So what I'm trying to do is I'm trying to figure out what number that 2, 3, and 4 can all easily become. 12. Now, 24 also works, it's just not the smallest. But because they can all become a 12, 12 is the least common denominator, and it will be the number that I distribute across the entire inequality. Now, that 12 does have to get distributed to all of the parts that are separated by pluses and minuses. That's 4 distributions then. This fraction, that fraction, that fraction, and that fraction. All 4 of them. And because 12 is a whole number, remember, it's only going to be multiplying to the top of the fraction. Because the bottom means divide by. No, this is multiplication. So I have a 12x over 3. 12 times 1 over 2, so 12 over 2. A 12x over 4. And a 12 times 1 over 3, 12 over 3. And after I reduce, I will have no more fractions. Except for maybe in the answer, but I'll have no more fractions in the question, nothing else to work with. Because 12 divided by 3 is 4. 12 divided by 2 is 6. 12 divided by 4 is 3. And 12 divided by 3, 12 divided by 3, we already said is 4. And there it is. Then it finishes up just like the last one. Move your x's to, because it's inequality, I always take the x's to the left. And the non-x's will go to the right. Oh, where's my green pen? There it is. 4x minus 3x, x greater than 4 minus 6, negative 2, finished. That's all there is to that. So that is how you deal with multiple fractions that don't have the same denominator.